Hello ladies and gentlemen, boys and girls, my name is OctoMan and today we are talking about prototyping a game like State.io. So State.io is some kind of a strategy game in which one or multiple players are going to be on one map. There's going to be at least one AI usually, and there are also default players, something like NPCers, not really want to attack players literally. So, how does the game work? Before we go into prototyping something like that, we need to understand the mechanics, of course, over here. Before we are going to go into programming and stuff like that, I want to explain the actual system of the game. So you understand it as well. And what I also want you to understand is that whenever you want to build a game like that, well, then feel free to do so. But usually, again, go into prototyping phases and stages and see, if the system would work, or you just rebuild other games in this particular case, meaning it's going to help you become better in what you're doing, grow in your skills and stuff like that. So usually, first off, what we do is whenever we start prototyping, we need to have an idea about the game we want to create. So in that case, I need some bases. So actually multiple bases, which do have, as you can see, multiple sizes. So, this is a State.io, meaning the players need to go over and capture the opponent's player, whatever capitals or cities or lands, or it doesn't matter. And there are also a bunch of other games about that, like where you have like virus cells, and there's just one huge cell for each player. So, and each cell over here is, I guess it's going to be some maximum numbers, is 50 of a big cell, something around probably 20 on a medium cell, and maybe 10 on a small cell. So this is what you need to understand first. Next one is you want to know, okay, what is this 50 about and where do we start? Well, usually these default ones, no matter how high they are, usually start at maximum amount, probably. You can actually later on go into that. So what does that 50 mean? Is in this city can live up to 50 maximum, let's say, people or whatever. Or fighters, or if it is a spaceship game later on, then it can hold a maximum of 50 spaceships, for example, to overtake other nodes over here, or other, let's say, planets, or whatever you make this game to. So the theme, as you can see, can be totally different. So it can be even a cell, it can like a virus, it can be a spaceship hangar, it can be a state, it can be a city, it can be anything. Okay, so what you want to do is what we want to create actually is we want to make sure that the we have a mechanic in which these numbers in the cities are growing automatically over time, like every once a second, for example. We're gonna get one more living something inside our cell or in our city or in our state. And when we have enough, we want to, well, at least one, of course, we want to make it so that we are able to send these people like a specific amount, or probably the maximum amount is going to be the easiest one. We take the complete amount over here and send them into a cell, whichever we select. Like we need to have a mechanic which whenever we hold down the left mouse key or touch on the screen, if it is if it is a mobile game or something, when we keep touching, then we drag somewhere. Wherever we let go, we see if there's something under our thumb or under our finger or under the mouse. And when we let go, we're going to send the units from here to here. And whatever the amount over here is going to be reduced by the amount incoming, of course, because they are kind of fighting probably. And so there's going to be some mathematics involved. So 50 minus, if there's going to be a maximum of 20 over here, minus 20 is going to be 30 in the end. Also, once again, the cell is going to constantly create creatures or cells or whatever, or human maybe, to make sure that the cell can reproduce numbers as well. Then when the cell is overtaking this one over here, for example, then it turns red, and the red people, the red state literally gets more in the total meantime. And in the end, you want to make sure that you overtake, like when you are the player over here, we need to create an enemy, of course, which is going to AI based steering or whatever, which is going to do the same literally on the other side. And the These ones in the center, which are going to be like, well, default or something like that, they don't do anything. They just stay there and keep the cells growing. Like if you send in 6 into a 10er, they're gonna regrow until they reach 10 again, something like that. So these are the mechanics we need. So we need to have a growing numbers mechanic over a cell. We need to have a tintability whenever or whoever is overtaking this state. So we need to have somebody or something to take a look into who is in the cell. Probably just an enum or something like that, depending on how many CPUs we are going to have or how many players are going to play. And of course we have the default ones which just keep on growing. So these are the different 3 things. Then we're going to have the sending parameter, so send from this cell to this cell, depending on how we want to create that. That's why we prototype that. What would be the easiest? Maybe we just select once and select the second time, and meanwhile we haven't selected the second one. We probably create some kind of an arrow or any line or anything in between the selected node and the node to talk to or walk to. And then we send some, let's say, little units. I maybe make them rather small. Whatever the amount is we are going to send, we want to create them or instantiate them and send them to wherever the direction of the cell is. So this can happen in 2D, this can happen in 3D, and all of that is totally up to you. Also how you want to, let's say, visualize that. You can put them all in one line or all on one spot like a big bubble. You can take multiple and so on and so forth. Again, this is also totally up to you how you want to manage that. And once a group is landing over here, the calculation goes like, okay, whenever this group hits this ball, there's a collision probably happening, and once that is there, then everything is good to go. Also, everything on the way to this point should be ignored except the point itself, like the aim, the goal itself. So once the players over here are going to hit that, then they reduce the amount of the people living inside the city, as an example. Good. This is what we need to do. To understand that, to prototype, we need to be as precise as possible. Good. Let's try to build some prototype based on this idea. By the way, if you guys have any questions or something or commands or whatever, just feel free to use the comment box down below or the chat and type in any questions if you have any, and feel free to, and I try to explain that. Oh, by the way, this one has been some kind of a request over here, so I was interested into that kind of as well. Okay, I'm gonna make a little break for a minute and then I come back and we're gonna start in Unity. Okay. So once we are in Unity, we need to decide how we want to set this one up. We have the possibility to put some 3D objects or 2D objects. Usually I prototype things in 3D because for me it's actually easier. Probably in 2D for you guys is better, so totally up to you. And of course, meanwhile, thinking about the mechanics, like the programming mechanics, we're gonna start really from scratch usually. So first off, whenever you prototype, use simple objects like squares, cubes, triangles, whatever, simple shapes, whatever you got directly from Unity, or maybe you create your own, totally up to you. Just use a circle, a pixel, or whatever, it doesn't really matter. Or just a sprite, just a simple one. It doesn't have to look like anything. Okay, so let's assume this is going to be a capital. We can also name this whatever we want to. Capital. It can also be a node. You can name this again whatever you please and like. It can be a city, it can be a town, it can be anything. If you want to be a bit more precise, probably we can also put something like a plane below our playfield. Doesn't really actually matter, but let's create one. This is just our ground over here, so we don't confuse ourselves, and we're gonna have something to work on, let's say. This is usually 1 meter by 1 meter by 1 meter, same, or no, it's 10 by 10 by 10. So the capital is going to be a diameter, I guess, of 1. So it has a scale of 1. As you can see, 1 grid represents 1 meter, so always keep that in mind. Okay. So we don't need to reset anything, or maybe we do, it doesn't really matter. So we also want to take our capital over here, and probably I'll rename this later on a bit. So it comes with a 3 collider, which is absolutely fantastic for us. We just need to modify that later on kind of bit. I'm gonna, let's say, don't lift it too much, I guess on 0 over here, so it looks like, let's say, a dome. So you can make it a sci-fi game where robots are going to go around, whatever. However you want to have the camera later on is totally up to you. So this is not really important, I would say, for a prototype in any manner. But you probably want to, let's say, make it so that you can visualize that for your own and probably later on decide differently. Always keep in mind that you work in 16:9 or 16:10, some fixed ratio inside the game view. Otherwise, you're gonna hate yourself later on for UI space content. And I'm gonna select my camera and go to Game Object Align with View. So it's taking the view of my scene view over here, kind of close. So I can also bring this left and right over there, totally easy. So next one is I'm gonna create some material over here, so we have a difference between the, let's say, 3 or 4 different things. Like I create a new material. If you're working with the different render pipelines, which is rather bad for prototyping itself, then just go and make sure you use the correct materials for that, like the HDR pipeline and so on. Okay, so I need a ground material over here. You can also later on go with terrain and stuff like that, something fancy. But in a prototyping phase, you want to keep that as simple as possible. I give that a little brownish tint maybe, so we have something to look at. Also, I want to make it so that it is not reflecting any light from wherever the sun is coming from. So we can go down over there and can say specular highlights off. And reflections, we don't need any reflections on that. We just need to have probably the shadow casting over there. Okay, so we have this one sphere now. I'm gonna can reproduce that so I get an idea behind or about it. And next one is we want to make it so that we have like a number sitting above, let's say, our first capital. We can also again create multiple other materials. I can also say Control D on the ground material, rename by F2, and can say something like red, and we tint this one red. Super simple, nothing fancy. Take a nice picture or a nice color if you want to. We can also say we take a blue one over here, so F2 for rename, blue, and then we can just rename that and tint that with any color, something like that. Okay, so once again, don't forget, you always think about prototyping it. You don't want to make it beautiful from the first place. You can do beauty later on. So then we have a bunch of in-between nodes, which are gonna have multiple different things around them. But let's start with coding, actually, since we need to understand some mechanics over here. So I create a new C# script. Usually in prototyping, you still want to work clean, so I'm going to sort things out in a second. So I just named this one, let's say, node, because everything kind of is based on that. Something like this is going to be kind of a node, this is kind of a node. All the in-betweens are literally, for me at least, are kind of a node as well. I can ignore all this stuff. I just clear the console and create some new folders for materials. So my assets are always sorted. So whenever I search for something, I know that where they are. So I put all the materials in the materials folder, create another folder for scripts. And if you go editor scripting, of course, you need to go and create your editor folder, but we don't. So I can open this one, need to wait a sec or two, and I open the C# script before. I don't really need to put it onto the capital yet, but there are things we need to take in consideration later on. I hopefully open my Visual Studio, whatever you're using. In my case, I still use a rather old mono developed version. Probably I'm gonna upgrade mine sooner or later, but for the moment it works. And everything is good, except some small things, some issues. So make sure your Visual Studio always works as it should be. So your mono behavior color, this color should be light blue. If it's not, feel free to check the internet. There are a bunch of things you need to take in consideration over here to make 100% sure you have autocomplete, also called Intelli something, is installed and your Visual Studio works 100%, or any other IDE you are using. So when prototyping, we want to make sure that, of course, we first off type down whatever we need. We need some numbers, right? We need some integers. Something like we need a maximum number per node. So max number or max, I don't know, amount. This is going to be the maximum amount this one whole node can hold. We can later on go with scriptable object if necessary, but not really at this particular point, I would say. And we can start with a number of 20 over here. So each node can later on be different, and we can override this maximum amount based on a node type. And this is probably something we can introduce over here, something like a node type. It's going to be not a normal variable over here. We are going to, or I would use an enum for that. So I can differentiate between different node types and can, for example, set the max amount at the very start of the game, of the round, depending on whatever the setting is. As an example, there are hundreds and thousands of possibilities, trust me. We could also say, no problem. We can go into it and say, hey, no problem, we're going to use a scriptable object for that, and each node type just inherits, well, node or whatever, and then we just read in whatever is inside the scriptable object. Once again, it doesn't really matter over here. So what I would say is, since there are 3 different sizes, I can say something like we have a big city, or a big capital, or big whatever. Then we're going to have something like a medium underscore city. Again, it depends on what your game type is going to be about. We need to make a comma over here, and a small underscore city. Again, you don't have to do it with big letters over here. You can also make it small, or whatever. Totally up to you. To access this enum, we need to have a public accessor for that as well. So public, well, then we just need to say node type. Actually, not node, but node type. I should make this one a huge letter over here, and here we can just say type or node type once again as well. So we have a decision-making system. Next one is we can say in our void start. I know I deleted this one at the first place. We can define, okay, whatever the setting of the type is, we can say the maximum amount of this particular city type is going to be 20, 50, 30, whatever. We can set this up as we please and like. Again, we can also put in a normal class, which doesn't, doesn't care about this, because maybe each different city has a different speed or something in which we're gonna go and upgrade or get more units or whatever they are in the cities or humans. So we can iterate them through a class, like we loop through all the corresponding classes, or each one is taking care of its own. So again, totally up to you and me and us and whoever is playing, or actually playing around with the prototyping thing over here. So what we can now check is what is the actual type over here. We can use the 3 if statements, like if big city then do max yada yada yada, or if medium city then yada yada yada, or we can also create a switch, probably out of a switch already, right? What we can switch is actually the node type, in that case the type. And then we can create cases for that. So for whatever case, so if the case is actually we type in case, then we can say node type dot, and now we can differentiate. Is it a small city, a medium city, a big city? I'm gonna take a small city as an example, and at the very end we need to put a colon. So whatever this case gives us, we have to do something, and then we need to break out of the switch. And so we can now put in any numbers in between the case and the break. If you want to make your life easier to read, for example, you can also put some curly braces. You don't have to. It's just a visual, so you know where you need to put the content for this particular case. Again, you don't have to put those parentheses. Absolutely not necessary, but sometimes it's easier for us. So I have 3 types to switch. So whatever the type is currently being selected, well, then we're gonna check that out, or we're gonna do some settings. So if we have a medium city and if we have a big city. Good. So in that case, we can, for each city based on that, we can set the maximum amount. So as you can see, we can just get rid of that, and we can now say the max amount of people or whatever is equal to what are we? Small. Let's say 10, because we were thinking about that at the very beginning as well. So a medium city can probably hold up to 20 or 25 or whatever, and a big city probably can hold 50. Again, these numbers are totally up to you, depending on if you have multiple more cities later on. Maybe you have 5 different ones, then you can also set a 40 or 25 or somewhere in between, or even ultra huge like a boss cell, which can contain even 100. Let's say we're gonna implement this. We can put this wherever we want to. Let's say boss city can be also a type. And of course, we don't need to create the switch for that if you don't use it, but we want to, right? So if we have a boss city, we probably need to get rid of 100 guys inside the boss city. And probably the boss city later on creates more or less over the time, but well, we'll get there. Now what we need is the current amount. So this basically we have a start amount and the current amount. So current amount, which is going to be set to be start amount, and then we have a start amount. I can put this wherever I want to. Start amount. We can put this like everywhere going to be the same, or we can also say each city starts at a different size. Well, doesn't really matter at all, I guess. So now we have a start amount, a current amount, and in start, let's say our start amount on each node is going to be equal to 10. And of course, we have the cap based on the max amount set in the very start over here. And what we want to do is our current amount is equal to start amount. Like in the very start, we just initialize that so we don't have to type things twice or 5 times. If you want to make the start amount per each, let's say, node separately, then you can also make this one a public one, and then you can set them by hand, literally. So bigger cities probably start at 20 and not at 10, whatsoever, up to you again, and the play style. So for me, I just keep them private because currently I don't need to set there anything at all. Now, how do we produce units? Let's say void. And I create a produce unit, whatever I call it, or produce a human, produce something. This is going to be happen once a second. We have multiple possibilities to call that function. We can say we do invoke repeating is going to be the easiest. We just say, hey, invoke repeating this one thing and produce one. And if there's one too much, then get rid of one or keep the maximum over here. So in that case, we can say our current amount plus plus, so we increase that by 1. You can also type in plus equal 1, and then the next thing is you gonna restart that thing actually. We wanna and then now we need to do some UI stuff here, so we need to see what the real amount is going to be, the real current amount. And then we need to do some measure. Maybe we do the actually a check for the biggest amount over here. In that case, we probably want to update the UI after doing the check, something like that. So first we increase the amount, then we go to check the amount. And in this case, we want to say if the current amount is actually bigger than our maximum amount, then we want to say the current amount. I want to say the current amount is equal to the maximum amount. So we don't overtake it, we don't overdo it, and we make it so that it is, taking care of itself to not overrun itself. Then we update the UI, lie down whenever it's done, and that's it. Now again, how can we produce a unit? We have 2 possibilities. No, we have even 3 or even more. We can do an invoke. We can do an invoke repeating, or we can use a coroutine. We can use the update loop. I recommend not using the update loop because the update loop should only be for inputs. What is an input? Mouse input, keyboard input, a touch input. That is the only things which should go there. Every method which is called from an input is, well, of course, a good thing, and can be called from the update loop whenever you do a touch, a press, a mouse click whatsoever. Good. Now we have more things to do. First off, let me produce a unit. I use a coroutine over here because probably it's not the easiest, but maybe it is. So it's called iNumerator, which is a coroutine. You guys probably know that already. And I just say produce, whatever. I don't want to name it the same way as this one, otherwise I get probably some issues. Then, since that is going to be a constant running, except there's maybe an effect on it, but currently we don't plan in any effects, we want to keep this coroutine run 100% and totally and always, constantly. In that case, we can put in a while loop over here. And this while loop just gets one argument, and the argument is true. So while true, keep on running whatever is inside this while loop. In this case, we want to say yield return new, wait for seconds. And then we want to wait 1 second. I guess there's also one other way, which probably is a bit better. It's going to be wait for a second real time. As you can see, it suspends the coroutine exception for the given amount of seconds using the unscaled time. So we are using scale time over here, I suppose. So in that case, it's not always 100% 1 second whenever wait for a second is going to be called, but it's probably the easiest for you as well to understand that. Next one is after we are yielding and waiting for 1 second, we want to call the function produce our unit. This one. And as you can expect, we are inside this while loop, so it keeps constantly running over and over and over again. Wait a second, produce a unit. Wait a second, produce a unit constantly. And always checks, am I full already? Yes, no. Am I full already? Yes, no. And it updates the UI once we got there to put it in. So basically, at least for the moment, that is everything we need for the city. Of course, we need to do the input stuff, in which we have like multiple possibilities as well. We can use a raycasting, we can use just on mouse over, something like that. We need to keep track on if something is selected already, but that's what we do in somewhere else. Okay, cool. So we now have a state which produces units whenever the script is running. The only thing we need to do is we need to start this coroutine over here, which we do in the start as well, like after we are done with setting our type, like the type of the city. That's called, this is called start coroutine, close parentheses, and now you are up, it's a bit up to you. You can store this coroutine somewhere, you can use it with, or start it with quotes, so you probably can end it later on, or you just type in the function. In this case, we can also say produce. This is usually used only whenever we, need arguments inside the coroutine. Currently, we don't need an argument. So again, you can call it this way. You can store it this way. You can also use quotes with also the pair of parentheses in the center to call this function or to start this function. There are a bunch of possibilities. For some are reasons, for them are not. Okay. So now, again, the city constantly produces, and every city is going to do that. Every city which contains a node class or a node script on it. Let's try that out. We can debug that easily. Even if the numbers are, let's say, invisible. So I have a capital over here. I'm going to put this node script over there. You can see, okay, the type is a boss city. Well, I want to make this a big city, not a boss city. And I want to go to the 3 dots, and there's a debug line over here. When we are debugging things, we can also see private variables over here to take a look into. Like we see the maximum, the start amount, the current amount. You can also use serialized fields and properties and yada yada yada. Up to you. I don't go too far in prototyping things. Whenever we start playing right now, you can see the maximum amount is set to be 50. The start amount was 10, and our current amount, as you can see, hopefully you can see that, it's quite small. It's constantly going up once. And as you can see, the current amount is now 23, 24, 25, and so on. Like once a second, or kind of, it's close to 1 second. We want to wait now, or I want to wait now, if it is possible to overdo our actual current amount. What I set at this cap to is literally that if the current amount is bigger than the maximum amount, that the current amount stays the maximum amount. And now we are at 50, and you can see it stays over here as long as we use these units. So this is the first part we needed to figure out. And this is working pretty good. I go back to normal mode since I don't need to see the debugging lines anymore. And again, don't forget, if you have any questions, feel free to go and write some comments down below, or put in something into the chat over here if you want to know something specific or whatever. I don't know. I create now another material for a node in the center on in-betweens, like yeah, what did I wanted to do? A material which is going to be just like a grayish material, gray, which is only for those nodes in the center which are probably well, what shall I say, which are by NPCs, kind of NPCs, like non-playable character, which are not doing any steps. They are not being able to be put it in, or there's no possible input over there. We can, for example, duplicate this capital over here. I'm gonna bring this there, tint it. It is going to be maybe a medium city, and what we can do is we can scale this one down, so we see a difference in the scale overall. I believe I cannot snap scale that, well, at least not for the moment, so let me pretty quick check my grid snap settings. Scale, so maybe I make the scale to 0.5 each iteration, so I can scale them. Yep, that's good. So I can hold on control and snap scale downwards, so I have now on each 3 axes a 0.25 reduced. So, and this is going to be a medium city right now. And depending on if that is somebody from our nation, we haven't touched nations yet, like a nation in case of this is my nation, this is the nation of somebody else. We should make them possible to be selectable or not. So you can create your own node system over here, it doesn't really matter. Again, you can do this in 2D, same thing. There's nothing different over here. And what we want to do is we probably want to make 2 of them, small cities, and I'm gonna scale them to 0.5 down, so we see difference over here as well. I'm gonna do a small break once again, and we are continue back in a minute or something like that. Okay, let's continue. So we now have a node which is able to create itself depending on whatever type of the node is going to be. Like this is a small city, this is a medium city, that is a capital, big city. And this one here does not have any script, so we're gonna put our node script onto this as well and choose big city. So it has a 50 at maximum as well. Again, starting point is always the same of all these ones. Later on you can also create prefabs, so whenever you do one change, you can do the changes to the other ones as well. Good, next one is I want to see that. Probably it's not necessary to see that at the moment. Maybe we do something else. Let's put in some selection mechanic and probably also see who's who and what is what. Usually when it comes to player input, we maybe want to see if that node, what is the faction of this node. Let's start with that. What we can do is we can create another enum which contains the different factions or possible factions over here, which gives us more or less a bit more freedom on the one side, but also on the other side we can determine who is my faction, who is the one I can literally touch over here or select. At a specific point, probably it becomes a bit heavier to handle, meaning maybe later on we need to create an extra class to inherit from, since it probably is easier to check who is in which class by iterating through a list or something. But we'll see. This is the fun part about prototyping. We don't know what we need to change later on. We just think about, okay, where do we go? What do we need? And where do we want to go to? Let's say this is is it called fraction or faction? I don't know. I guess it's fraction. So the fractions. We have an NPC fraction, which is kind of a default and non-attacking. You can also do commands over here. Non-attacking. Then we do have, whatever, an enemy. Maybe we have multiple enemies later on. We have a player. Or multiple players. Again, depending on how far you're going to go, you probably need to create another script or class which contains all of that, so it's easier to understand how many enemies we do have. Like this way we probably cannot have multiple enemies, but we can actually see if that is an enemy. So an NPC literally is also, for the player at least, is seen as an enemy, so the enemy sees an NPC also as an enemy, because the enemy wants to overtake NPC spots as well, whenever it comes to that point. So what else do we need? Well, whenever we are starting our round, our game, we want to see, okay, who's who and what is what. So, we need a public accessor for the enum actually, before we can go forward. In that case, it's a public fraction with a small f at the second time, so I can simply, typo. We can simply take a look into uncheck against. Now we can select a fraction. So this is going to be the player fraction at the very start, and this is going to be the enemy fraction at the start as well. And all the other ones are going to be NPC fractions, as we can see over here. Pretty good. What I want to do is I want to implement TextMesh Pro, in which we need to import the TMP essential resources. If you haven't done this yet, anytime you're going to create a, let's say, UI, something, then you need to go and use that. You can also use the Unity provided text, but the TextMesh Pro can be reduced quite small and looks pretty good in the end, or actually better in the end than other ones are going to do. Yeah, I'm gonna go and import these pretty quickly. So there's one or some text elements inside. So I can use these also in scripting, so I can update text inside TextMesh Pro elements and all the other good stuff. So what I want is each capital, and this is where it becomes better to create prefabs out of, which I should have done before. Needs to have a canvas now. So I create a new UI canvas. As you can see, it's rather huge. So I want this to be a world space canvas, and I reduce, or actually set it to 0, 0, 0 positioning wise, and make it a 1 and a 1 in the width and the height. Of course, it doesn't look to the camera yet, so I need to rotate it. I'm gonna hold Control so I can snap rotate things. Later on we can also go in and change some stuff about, you know, look at the camera things, something like that. So this canvas should now contain TextMesh Pro text, actually 2, I guess, with some numbers. So the biggest is probably the 50. As you can see, it's quite huge. So I can go and first off, let's see how big it is. We want to maybe put auto size on and center this one out. And it depends on, again, how we want to see this text to appear. We can do something like 50 minus 50, so 50 out of 50. We can also say something like 50 out of 50, like that. Probably it's a bit easier to read later on. So in that case, the width and the height is rather huge over here. So we make the width and the height a 50, 1 and a 1, at least for the moment as well. But as you can see, the minimum number over here is too huge. So I reduce that down to, let's say, 0.2. And that should fit it. But as you can see in the camera, we are not able to see anything. So later on, we need to take a look into this. So for the moment, I just go and, well, don't rotate this. Probably rotate the complete canvas so we can see these numbers going on over here. Don't forget to center the canvas. It's just lifted up a bit, 1, 1, 1, and the numbers are going to be inside the canvas. Pretty good. If you don't want to see these actual gizmos of the TextMesh Pro, you can always go inside and deactivate them inside here, or just disable gizmos completely. Again, totally up to you. Okay, so let's update this one. Since the Capital now has a TextMesh Pro, we can also, and this is the cool thing, once we are done with that, we can update these numbers, and then we create a prefab, and then we need to recreate all of these nodes here as well. In that case, we need to go and implement the actual text field over here. I have added the TextMesh Pro, that's why everything is red underlined, so I hope that's working now. If not, actually, no, it's not working. So I need to go and restart. I need to restart my script over here for a second. So I need to reopen this one. Again, if you have any questions, feel free to ask in the chat or comment down below. Once again, make sure everything is connected, everything is light blue, or whatever the color scheme of your IDE is going to be. Using TMP Pro, or TM Pro. Actually, this is the namespace we need, otherwise we don't have access to TextMesh Pro elements. And now we create a new public TextMesh Pro asset, and it's going to be TMP_text. And we're gonna give it a name. This is going to be our amount text, something like that. We don't really need anything else, like in this case. And we now want to update the numbers inside the amount text whenever we do update them. To do so, I create a new void update text. Update text, or you can also name this amount text. So every time we do an update, we want to update that accordingly. In that case, we want to say amount text dot text. Now we do some nothing actually. We don't really need to do anything. We just say current amount. Then we add 2 pluses in between. I'm gonna put a quote and a slash. You can also use a pipe or whatever symbol you like in between, or a colon. And then we need to take the maximum amount. We want to see that actually inside this update text. So the text now updates to whatever the current state of the maximum amount based on the current amount is. The only thing we need to do is we know whenever we produce an item or a unit, we're gonna here have to call update amount. We need to do the same after we are setting the current amount to the start amount over here at the very beginning as well. Don't forget to save as usual. And then we need to go and select our first main capital over here and need to drag the TextMesh Pro component inside this field. Pretty good. Now I create, maybe I rename this to be a node, and put this into a prefabs folder. Prefabs. Actually, that's wrong naming convention. I'm gonna rename that again, prefabs. And I now drag the node inside that. So whenever I do a change to the node, the color actually doesn't really matter. And same for the settings, we can override the settings whenever we start that. Okay, I get rid of the other capitals just for a second again, and make them so that they're part of node. Like I duplicate now my prefab. As you can see now, the text comes with it and the setting stays. There's also a big city, pretty good. I just need to give it again another color or material, just a blue one again. And the faction is going to be an enemy faction, and so on and so forth. I can now duplicate this, do some settings to that. So these are my NPC settings. You can see whenever this becomes bold that the the prefab has not stored this information, and you shouldn't override them as well. So I put the gray material on it, and I scale down to 75. As you can see over here, it's also bold numbers, so these are not stored in the prefab, not even automatically, not even overridden, not yet at least, but you shouldn't touch these numbers. And the last one is, this is going to be a medium city, and it's an NPC type. And now I can Control D to duplicate again and create my map again. And now I can create the last two ones, which I have in small cities. Gonna scale that down once and put these, I don't know, somewhere in between. Whatever. Good. Don't forget to save your scene. And now whenever we start the game, we should see those numbers looking different and updating themselves. As you can see now, all of them are updating based on whatever the maximum amount is. This are 10, 10, 19, 20, 20, 20, and the big ones are going to keep continue until they reach the 50. Good. Our cities are done. Now we need to determine, okay, who's who and what is what. And once we are selecting something which we own, we are, if a node is a player node, then we can make it selected. And once we have it selected, we should be able to select something else, which is A, our own node, or B, another node. So we can add or decrease from that current specific node whenever we have selected one. If we haven't selected one, and if it is not our node, like our in case is not a fraction of player node, then we cannot do any inputs to them. The enemies are going to do different things, I guess, later on, but I haven't thought about that yet. Okay, so we have two possibilities. We can, to select something, we can use the on mouse down event or on mouse over, and then whenever we do a mouse click, or we use the update loop with a raycast. Basically, if you're doing 2D or 3D, also shouldn't really matter, depending on what you want to do. But if we want to shoot a ray to our obstacle, see what we hit, and then we can check if we hit something which contains a node, and if that is the case, we just see, is it the player, is the faction a player, then we can do something with it, otherwise we cannot. So, to do that, we have, again, multiple possibilities. I guess we are creating something called a game manager. Well, I name them game manager. You can name them whatever you want. You can also name them just input or input manager. Input manager, because this is only handling input for us. In this case, touch input, mouse input, whatever. And the rest can be done in the game manager later on, to like all the mechanics and stuff like that. Like whenever we touch something or press on something, we may want to recognize who is currently selected. I guess we don't need start, we just need update. And once again, the update loop is only for inputs. Only. Do not do anything else in there. Even if it is easier, because it runs 60 times a second, and you don't need to run things 60 times a second. Okay, so whenever we make a left mouse click, if input dot, what is it, get mouse button down, I guess. If we do a click with the left mouse button, in this case number 0 over here, we want to shoot a ray. We want to shoot a ray from the mouse position into the camera space position thing. In that case, we can create a new ray. We name it ray. It's equal to camera.main. I guess screen point to ray, or screen to, I guess it's screen point to ray. Now we can put in any position. Should be our mouse position. So input.mouse position. Input.mouse position. If that is wrong, we're gonna change that. Or we can always use the what is it called? the scripting reference to see how raycast inputs can work. No, we need to do this. Now we need to store a raycast hit. So whenever we hit something, we store it in there, and then we do something with it. Now we do the physics check. So if physics dot raycast. Now we need to put in something. First off, we need to pass in our array. We are shooting from our mouse position into camera space, literally. So we need to tell out hit. We can also define a specific layer to check, but we need to make sure that we introduce a length. Otherwise, there are sometimes weird things happening over there. We don't need that. Well, actually, I don't think we need that. Once we are shooting this ray to a position or to an object, we want to get some response. And the response is usually coming from the hit itself. So we can check against what did we hit. So if hit.collider... actually, well, let me do this different. We store what we hit, and what we want to know who we hit or what we hit. We want to know if there was a node. So we catch whatever hit.collider.getComponent of type node. So once we get that something, if that node returns not null, that's what we can check against. Then we can check against, okay, what do we hit? Or we can say, whatever, do whatever, or request a fraction we have selected. So if n is not equal to null, so we have found a script on whatever we were touching, because the plane on the ground also has a collider probably, or maybe there are units we don't want to hit or want to select. We only want to select the capitals. Then, so if n is not equal to null, then we can do press or shoot out something, debug.log, and now we can say n.fraction, for example. Let's try that out. Since that is only taking inputs now and it doesn't care about anything else, this is just taking care of that. I create a new object, so I need to put my input manager on top of that. So we can say game manager. Maybe I'm gonna put some dashes around it so I find it easier later on if the scene would be fuller or something. And onto my game manager, I'm gonna put my input manager, later on my score manager, if there is some score to reach, I don't know. I save my scene, Control S for quick save, keep that in mind, makes stuff easier. And now let's try to select something and maybe we get something into return. So whenever I select this red one, you can see we know that this is the player fraction. If I select this one, you can see, oh, it's the NPC faction, and this one here is the enemy faction. Pretty good. So input is kind of done. We just now need to say, okay, whenever we have this one now, whenever we touch that, we want to make this one, whenever the faction is correct, that this one is a selected one. If we select nothing, we want to deselect probably whatever we have selected. Like if we touch the plane, or if there's nothing, we probably want to deselect. And if we have this one selected and we select something else, then we send all the units to this. Let's try that out. I don't know. Again, prototyping can be fun. Prototyping can give you headaches. So this is what I guess we're going to try out over here. We don't go into instantiating all the units yet. We just want to get the pure mechanics down, just to get an idea of if their things are really doing whatever they should do, right? So now we know what is the fraction or the faction, whatever. Whoever we selected, we know if it is red or green or blue or whatever, purple, and it's just that thing. So we want to make it so that we have a possibility to make this one node, whoever this node is, that this is the selected node. How do we do this? Sorry, I need to close some things. How do we do this? I create a new C# script for that. It's going to be my game manager. And usually there is this, when you name it like with a big G and big M, and probably also with other typing things, it gets this extra symbol, this special symbol over here. So I put this onto my game manager object, and I open this in MonoDevelop, Visual Studio, whatever, by double clicking. You can double click here or here. And I make a small break for 1 second or 10 and back in a moment. Okay. So what we want to do is we want to store the selected node, if it is a player node. So first off, we need to check if that is a player node or not, and everything else should not be selectable by the player itself. So each one is only for its each player is only corresponding or is responsible for its own stuff and has nothing to do with opposite things. So who is the selected node? Well, we can make this public, but you probably shouldn't. So I create a new node over here with a big N, and I want to say this is the selected node over here. The selected node is the one which is, once again, only selectable when the player is pressing that, and if it is a node for the player or from the player, so we can act or react, meaning sending units from this node to the next node. So probably we need to have another node over here, which is going to be the next or tag node or the node to visit. Maybe we name it node to visit because it's not always attacking. Node to visit. Because there are two mechanics. The first one is we can destroy units which are inside one other node, but also we can fill up a current node when it is our own node. So that's something we need to take in consideration, and we need to switch colors or materials and so on and so forth. And even here, this is more important, probably later on. We probably want to set one specific class for each possible, let's say possible, for each possible enemy or for each possible player in this case. So each one has its own color set, its own whatever speed of units and something like that. But again, this is something we don't really need in the prototyping stage, but that is where you can actually start to fine-tune. Okay, so we have a selected node, we have a node to visit. The node to visit is the second one we are pressing after we have a selected node. If we press somewhere else and the selected node is empty, we don't send any units over. And this is what we also need to put in later on inside over here. Like whenever we select something, we need to also check if we have a selected node already, and if the node we are currently clicking is A, not the same node, and B, is any other node, literally. And it basically doesn't matter what it does. And the units are reducing or increasing based on whenever they hit probably the opposite node. Whenever they hit, they increase or decrease the amount of units which are inside. If it is an NPC, then it switches that literally to something else, and once it's switching, it also switches the color and so on. But again, we're gonna get there, I guess. Good. What do we need to do now is, if that node is not null, we want to go and talk to the game manager and update it. To update the game manager, we actually need to make it so that it has a singleton. So in that case, a public static game manager instance. So we can talk to anything and anywhere we want. We also need to have a void awake. No typos, with a big A, absolutely important, in which we just say instance is equal to this. So it's only one instance, well, literally only one game manager instance over here. We don't need to take this into other scenes and stuff like that. There are other ways to do this, but for the moment we just say we want to have instant access to the game manager whenever we need to. We create a public void I don't know, handle nodes. And this handle nodes literally can take a node as an input, a whole node n, or just small node. And depending on, maybe we need to have a second function, I don't know. One node needs to be, we need to set the selected node to be this node, only if that is probably empty, but if that is, it can also be null, so we can also deselect literally this node. So literally, let's say handle a selected node, at least for the moment. We can say selected node is equal to node. So if node comes in here as null, then it should be nulled as well. And we can also pass back whatever the state of the selected node is going to be. But let's save that and go back to the input manager. And then here we can just say, we need to request, actually, before we can do this, we need to know if the selected node is null, I guess. So we're gonna do a public, we just return a bool if selected node is null. Node selected. We can also store a bool somewhere else. So basically, if selected node is not equal to null, well, we can also make an expression. Something like, we can say return selected null node. If that is equal to null, then we return false. Otherwise, we return true. I guess that should be okay. Simplify condition. Oh, yeah, basically, that's basically the same thing. So it returns the opposite of whatever it is. That's what an IDE is absolutely fantastic for. It will help you to simplify your code. If you don't understand it later on, of course, that's a different story. Anyways, so what we want to say is if game manager dot selected node. No, we need to talk to the instance first. Instance dot selected node, or node selected if that is returning true. Then we don't want to do this. Otherwise, we want to say handle selected node. Basically, we need to do this both. Yeah, basically, we need to do this 2 times. Actually, the thing is, we need to know if we have a next node or a selected node. So we can define maybe I can also do different things. We also need to have a deselection in place. Let's see. Maybe we can automate that, or maybe we let not the input manager handle that, but the game manager. Maybe we can do something like if selected node is not equal node and selected node is not equal to null. Selected node is not equal to null. Then our node to visit is equal to node. So basically we do select this first one. If a selected node is equal to the node coming in, we can say we deselect it. So we can null it. Selected node is equal to null. There are probably multiple things, multiple scenarios. Something like if selected node is... No, actually, if node is equal to null. If node is equal to null, then we want to nullify literally node. That probably is not even necessary. And if that is the case, we can send units. I'm gonna send units, which we do inside the node. Like a selected node is going to send the enemies or the players' units, whatever the maximum possible amount is, to the node to visit, and then we deselect them at this afterwards. These send units, and then we have deselect all nodes afterwards. In that case, we need to say selected node is equal to null, and the next node or the node to visit is equal to null as well. Not quite sure if that makes any sense. And in that case, we don't really need to do this. We just need to call game manager dot in. If it is not null, game manager dot instance dot handle nodes, handle selected nodes. We need to pass in n, which is going to be the node we found. The downside is currently we don't have any deselection. So maybe we do something like we could return over here. And then we can put an else statement, which can say a game manager dot instance dot handle selected nodes, and then we pass over null. Maybe like that. So we don't need this. So we handle selected node. So we pass in the node and see if the selected node is the same node. If that is the case, we nullify that. Or if the node is equal to null, then the selected node is also null. And of course, the node to visit should also be null. If there is something inside, probably. Then we literally can return here because we don't need to do anything any further. If the selected node is not equal to the same node and the selected node is not equal to null, basically we don't need to check that because we did that over here. Maybe we keep that in for the moment. We say the node to visit is the node and the selected node, yes, something like that. Maybe we can at the very end debug. Let's say here debug.log node deselected. So whenever we click somewhere else, we want to see if that fires. And over here we want to see who's who. Actually, we don't have a selected node. That's what I currently can see. So in here we say we null all. Actually, if the selected node is not null, then we do this. But we haven't checked if the selected node is null. So if a selected node is equal to null, then a selected node is equal to node. And of course here we should return as well, since we don't need to go further, I guess. So if we don't deselect it, selected node, and in here we should have the next node. So we can debug them as well. So we do a node selected, and here we have a visit node selected. Well, at least for a moment. Then we send the units later on. I'm gonna keep some space here. Don't forget to save. And let's see if that works. So whenever prototyping, whenever you do this out of your mind, you are never prepared. You probably want to take a look into and see if that makes any sense at all. So if I select this, I can say, okay, the node has been selected. If I click here, the node is deselected, which is good. So if I select this one, of course, I don't check for the fraction yet. I only select nodes. And now I have selected this one at the first, and the visit node has been selected, which would be this one. So in the end, I can now deselect all the nodes. I can select the start node selected, and I can say this is going to be the next node to visit. Then of course all of them clear. To see that even further, you can go and debug and see what is the current selected node and the current node to visit. For example, I click this one. You're gonna see this is the first node over here, and if I click this one, it gets selected, but it's getting cleaned afterwards. If I select this one and select the same again, it deselects it as well. So I can select here, select again, deselects. Setting or clicking anywhere, it deselects whatever has been selected. So if I click this one, we can also do some highlighting about that later on. Or you can do with some whatever ring effects, then you can do so, like show a ring around the node you have selected or whatever. Good. Awesome. So this works. So we can handle all the nodes coming in. Now we just need to send all units we got to the node to visit, and the node to visit has to actually make sure all works depending on what is the current state of the current node. So we're gonna use some what do we need? Some collision detection, I guess. So currently we know the fractions are based on these colors. So, and since each of the nodes currently doesn't know about the different materials or colors or whatsoever, probably we're gonna use material list or something, or an array. So we have like number 0 could be the player, some number 1 could be the default or the NPC ones, and the blue ones can be the other ones. We don't have any NPC stuff yet, but what we do have is actually the base mechanics running already. Let's see. So I would say we create a material array. I don't know if that is even working. Materials. So maybe you wanna go and again create a class for that. So each individual entity or a unit or class or fraction can hold its own information. So we don't have like everything inside one node or in each node, but for prototyping it maybe is going to be the easiest way over here. So we can do something like at element 0 we want to have maybe the NPC, so the gray one. At element 1 we want to have, let's say, the player, and at element 2 we want to have the enemy, at least for our little prototype over here. So whenever we are sending units, we need to create a public void send units, send units, whatever. What do we need to know is each unit we need to produce is based on the current amount, and we need to instantiate them. We don't have anything yet, and we need to give them a goal. For the moment, we need to pass in the node we want to travel to, because the node has an object and like an object, it has a transform component, and from this transform component we could even pass over the transform component, don't get me wrong, but probably need to pass in some other data later on to this one specific node. In that case, it's going to be our goal node, and we want to pass the information later on in each of them units, so each unit need to know where to go and what to do. We haven't done any units yet, but we will get there. So whenever we go and send units, we need to iterate through the maximum or the current amount of units. So first off, we say units to send is equal to current units or current amount. And then we loop through. So for int I equals 0, while I is smaller than units to send, we increment I, and for each anytime we loop through that, we just say game object new unit is equal to. Basically, we could even handle this one in the game manager. Not quite sure. Is equal to instantiate. Why do I say that in game managers? Because, well, otherwise each node needs to have a prefab of nodes. Well, actually it's a prefab anyway, so it doesn't matter. We can do this here, we can do this there. So what we want to instantiate, we don't have a prefab set yet. So, and we need to tint this by the material based on whatever the current whatever the current fraction is going to be. Again, a class would probably be easier here. So we need to have a game object, which is going to be a unit prefab. We don't need to tint it literally, we just pass over the material to the prefab and probably can reuse them. That's what you would do in 2D as well, by the way. So we want to instantiate the unit prefab. And where do we want to put this? Actually, at current position, literally. And why do I actually catch that new unit over here? Is because I want to talk to the unit and tell it, hey, you have to move to this node, and once you hit that node, get rid of it, or take it over, or change it, or upgrade or downgrade or whatever. So there's the management between the nodes, like do damage to this node or overtake the node because there's nobody inside anymore. But this node handling comes afterwards, after we are able to send those units to the point. So first off, we want to instantiate new units, and then we want to, let's say, tell the unit to move. And what we need to move them to is actually the goal node, wherever that is. Then we deselect that in the game manager anyways. All the units are going to become created, and they should move there. And once they hit something, actually not something, but whoever is responsible for this one specific node or object at this position or whatever, and no others, or probably enemy units, then do damage. Okay. Don't forget to save, and let's go and create a unit. What could we use? Just other small balls maybe, or we can also use squares. Again, prototyping doesn't matter. You can even use the nav mesh system if you want to, the navigation mesh. So each of them are not sticking onto one place, which could happen in our case. So probably I'm gonna give a small delay in between creating them or spawning them, so they are not like 50 on top of one. Or we give it each unit let's say HP amount based on the current amount, and then we reduce the ball over there, or reduce it first and then, well, actually it doesn't matter. So a unit, I need to create not an empty, not at least for this particular moment. I create a sphere maybe. I go out of the debug mode so I don't get distracted too much. I reset it, and I'm gonna scale this one down to small, 0.25. Should be okay. So this can be our unit later on. And we need to create a script for this unit so that unit knows what to do. Unit. Once the compiler is done running, we select the unit and give it the script in which it can handle 2 things, or maybe more. So first off, it needs to know where to go to, and second one, it needs to know what fraction this is, or something like that. So it needs to know where it comes from, where it goes to, what type it is, and so on, so to compare what's going to happen. So if the node of the, and that's where the fraction class, or a fraction class, would be probably the best way again. Each unit would know what fraction it is about, so we don't need to do all of that hassle with, you know, going back and forth. But again, for prototyping, absolutely okay. You can optimize the code later on, I guess. Everybody can. So every time I'm, with my old monodevelop, creating a new script over here or adding more components or something like that, I need to restart it. So that's why I have to do this. Gonna open the unit script, and we need to have an access point in which, or actually some settings. So we need to know what is the fraction of this unit. So whenever we set that we can compare it with the fraction of the other one. So literally, and this is the ugly part right now, we need to know 2 things, or at least just denote, I guess. We don't even need the type, we just need to have the fraction. So I copy that and bring this into the unit, because the unit needs to know what fraction type it is going to be. So if it is an enemy, a player, or an NPC, NPCs are really not necessary at this point. We only need player and enemy over here, but we need to compare them or set them to be whatever we pass in. And in that case, we need 2. Yeah, it might be better to have it inside the game manager or somewhere else. Who is going to overlook that? I don't know. So we create public function. This fraction doesn't even need to be public, but it's okay to check against that at least. And we need to have a void, and let's say we need to set the unit up. And what we need to pass in is a fraction, or fraction. We can name this, yeah, maybe I name this as it tells me, a fraction. And so once again, it's a bad idea to do this way, because we could have multiple enemies. In my case, we cannot have multiple enemies. But again, this can be optimized later on. Next one is, whenever we set the fraction, we need to set the goal node. So node, goal node. So we need to know where we go to. And we need to, well, probably can also pass in the material already. Material, mat. So we can tint the actual game object with the material, or give the material in of the current object the material we're gonna pass over there. So we have always the same material. Good. Anything else? Maybe the fraction. Maybe we need some movement speed or something like that. Float speed. Again, we don't go too much into detail over here. We just want to prototype and see if we can do that. So, and in that case, we want to move towards a point. We can do a move towards point inside a coroutine as well. We can also use the update loop again. If possible, avoid the update loop, which is, but that is actually the best or the fastest way to move a unit from a point A to a point B, by using the move towards function. Let's try that. Update loop. We can say transform dot position is equal to vector3 dot move towards a point from our current position, transform dot position, comma, and then we have the target, which is going to be the goal node. And I don't have the goal node stored yet, so we probably take the transform directly here. Transform goal, like that. And we take the goal dot position, And then we can define a speed. So speed times time dot delta time. No idea how fast they have to be. Probably we start with something like, I don't know, 10. Don't forget to save. And that's basically happening once we are done with all the starting and all the setting up the units. So basically we give the unit the okay to move whenever probably everything has been set over here. So who's the fraction? And of course we need to go into the like whenever we have the collision happening, then we need to handle whatever has to happen there. Like whenever a unit hits a node, it needs to see who is that, and we add up if it is our own. We add up to the current node, or like we switch colors and all the other stuff. So when we are setting this unit up, we want to set our own fraction. Let me rename this to be at least an underscore in front so I don't confuse myself. So fraction is equal to underscore fraction. Should work. Then we have the goal node. And actually what we want to set as the goal is equal to goal node dot yeah, probably get the transform already, not quite sure. And we need to set we need to get our component of type mesh renderer, I guess. And in here we should have a material. We should be able to set this one to be MAT for being our material, so we can tint the little guys, the little nodes to that. Once we are done with that, we can again do the transform position, move towards thing, or we can use an F mesh, we can do whatever, as well as we are able to say only if that is the case, then we do that. Okay, so whenever we are now we need to understand who we are colliding to. So on trigger enter. So whenever we enter a trigger, we can take a collider. Any type of collider should be fine. COL. So what we now want to know is who we colliding with. Is the one we are colliding with, is it the one which is the goal node? So if COL is equal to goal node or goal dot what could we do? Goal dot get component, probably of type collider. Not quite sure if that would work. If they are the same, so if that is equal to that, not quite sure if I never did this before. If they are the same, then we want to destroy this unit, and we want to do damage based on what is the fraction of the goal node. Maybe we should not take the transform over here. Maybe we should store the goal node. So we need to say game object of transform. Goal, no, actually that is wrong. Goal is equal to goal node, and goal dot transform dot position should be the one. So we have this out of the way. So whenever what we can also do is we can compare if the node we get the node we are colliding with first. Maybe that makes it a bit easier. So node n equals to col.get component of type node. So because we can also collide with something else, so we want to make sure that these two match. So if n is equal to a goal, then we want to do something. Of course, it needs to be equal. So we want to compare things. So if n is goal, then what do we want to do is we want to do damage to n. So we can now we can say just we create a function in node which is able to handle now everything. Like we pass back the fraction. We don't need to have the material, but we pass back the fraction, and if the fraction is this or that fraction, but not the same, then we reduce current amount, and if it is under that, we're gonna make the node to be the fraction of the unit. And if everybody else who's coming next is going to add to it, because it's the same fraction, then we increase the current amount, except it is at the maximum. That sounds kind of correct. So let's try that. Public void calculate or handle incoming units, something like that. Or unit, it's just each time it is a single unit. Actually, the incoming unit is going to pass in a fraction, and we want to compare if the fraction or the incoming fraction is the same. So if it's not, of course, well, we do handle different. If f is equal to fraction, so the fraction over here, that is the case, we can say current amount plus plus, and we want to update the UI, update the amount text, literally, something like that. So in that case, we can also return, because there's nothing else to do over here. Actually, what we can do is we need to tell, we use produce unit actually instead of that. So we have everything in place already. We don't need to do things twice, I guess. And we also check for the maximum content over here. So instead of doing this, we can just say we produce a unit, produce unit. Come on. And then we return. So we update the UI, we add 1 unit, and we are good to go. We return at this point. If that is not the case, if it is not our fraction, so the same fraction is not given, then we want to see, or we want to reduce current amount by 1, actually. So current amount minus minus. Then we want to check. Whoops. We want to check how much are here. So in that case, we literally do or should create another function, which is not producing units, but destroying or deleting units. Void destroy unit. And in that case, we need to know the fraction. We pass that over, or yeah, because we need to know who we need to change that to, and of course maybe need to handle fraction a bit different by using another extra switch component or a switch statement for that. So we automate setting the correct materials up, something like that. So whenever we destroy a unit, I'm gonna take this away and bring this here. Destroy a unit, something like that. And what we can tell is at this particular point, if current amount is smaller or equal, actually, yeah, smaller equals 0, then we want to do something. And in that case, if that is really happening over here, we want to change the fraction. So we want to say fraction is equal to f. And of course, we want to set the material to be whatever the fraction is. So in that case, we need to have maybe a fraction handler for fraction handler. Probably we can just switch fraction. Switch fraction. So at the first place, we can say fraction is equal to f. That's the same thing as we do here. Now we can switch that fraction with those 3 cases. So in case of fraction dot is enemy or NPC, colon, or somewhere. Then we need to create the break again, and whatever is in between we can do over here. In this case, we can set if the in the case of the fraction is now going to be an NPC fraction, which probably never happens at this point whenever we handle that, because the NPC is not able to overtake spots. So probably we're gonna start, if it is a player or become a player, fraction becomes. So fraction becomes a player, then we want to set the actual material. So we can say get component mesh renderer material to be equal to materials in square brackets. Well, now we need to check the number. In this case, the player would be 1. So we take the index number 1. We need to keep that in mind later on. And vice versa, if the fraction becomes a NPC, an enemy actually, then the material becomes a 2. I have a lot of... the switch ends here, which is not correct. So... okay, don't forget to save, and now we should be able to, this looks a bit bad here, let's sort that pretty quick. This is this and this is that. Okay, don't forget to save again, and now we want to destroy the unit, but we need to pass in f, which is going to be the fraction over here, I guess. Let's see how that works. Actually, it looks good. So final thing is, whenever we are now colliding, the unit is colliding with any node, and the node is the one we are moving to, then we want to do this handling over there and destroy the unit and so on and so forth. So in that case, we destroy one current amount whenever one unit hits it. Then if that is so, we change the fraction, and the fraction is going to be, the handler. And otherwise we're gonna go and produce that things. Oh, and once that happens, like after we are colliding with that, first off we need to say n.handle incoming unit. And once we are done with that, we need to pass in the actual fraction, I guess. Node fraction in unity fraction. Oh, these two fractions are not the same, and this is the actual issue over here. That's going to be, and this is actually now the actual issue. That's what I thought. So I take the fraction outside of the node class, I guess. Not quite sure if that works. So I don't initialize this fraction here, I guess. So toggle. Since I put it the fraction now outside of a class, it should be accessible for unit as well. That's why this is not red now. And now we should not have any issues with comparing a fraction 1 with a fraction 2. So our unit, once it is now colliding, it can take over this one fraction. So we are always talking about the same fraction, not two fractions literally. And they should be comparable, which looks correct. And they should be able to change material. Let's try. I hope I saved everything. And here's my little note. This currently is an NPC fraction, so it really don't do anything. And I make it a prefab. So you can name this one as being a unit. Make a prefab out of it. Get rid of that because I really don't need this. And each of them nodes now need to get the prefab. So as you can see, the unit prefab now needs to be dragged into here. And also each node now should have a set of materials, a list of materials. So let's take a look into the order again. The number 0 is NPC, number 1 is player, number 2 is enemy. So keep that always in mind that you take nodes. So I put this one into 1. So the player in my case is red and the enemy is going to be blue. You can handle this however you want to. Then we get out of the actual prefab again and hit save. Let's see what's happening. I have no idea. So I select this one over here and select this one, but nothing happens because we don't call the actual stuff to send units. And in this case, we should tell the selected node to send the units to the goal node. So the game manager now needs to say selected node dot send units to, and now we need to pass in the goal node, and the goal node is going to be the node to visit. Node to visit. What is it called? Yeah, node to visit. Let's see. Don't forget to save. And let's see if we can see something working over here. Pressing play. Oh, we don't compare. Oh, and then we get another reference exception in unit line 28. Unit line 28. Let's see, what is that? Okay, it tries to move to something. What is not possible? Good question. Oh, we don't set the unit actually, do we? Yeah, we don't do this, so we need to say set unit first. So new unit dot set. We don't have this one public. Oh, we do. Set unit should be public for us. Oh, we need to grab the script, of course, first. Oh, where did I do this? Here. So we need to grab now. So set unit dot get component of type unit dot set unit up. So now we need to pass in the current faction. So the faction we have set before, like which is on top of the node. Then we need to tell where's the goal to go to. Question mark, and in this case it's going to be, of course, goal node. Goal node. And then we need to tell the material, and the material once again is the one which is the current material, literally, or yeah, how do we do this? How do we make it? Actually, probably we can pick that based on our fraction. Actually, we don't really return anything over here. Maybe we do something like get component of type mesh renderer dot material. I don't know. Something maybe like that could work. And the null reference is the goal hasn't been set by us before trying to move to the point, I guess. And there was one node moving over. So whenever we send that, the units to send, afterwards we need to say current amount minus equal units to send. Maybe we are gonna put this into a coroutine to have some waiting time so we can see multiple nodes going over to the next point. And probably reducing the speed as well. What's really happening? Question mark. So I take this, I take that, but this one does not update at all or even handle everything. There was some ball going over, which is good. And this one works now as well. Probably I'm gonna do it like putting this one, the send units stuff, inside a coroutine. Maybe it's a bit better. So first off, I need to have a public accessor for that. Basically, or just let me create the coroutine enumerator. Send all units. Oh. So in that case, we go in here, we iterate through something, wait for a second, and then do this the next thing. So create that. I basically do the same thing as I do here. Oh. I don't know the goal node, so I need to pass that over here as well. And over here, I just get rid of that and just start the coroutine. And since I need to pass over the argument of the goal node, I need to do send all units and need to pass in the goal node. Why putting this into a coroutine is rather simple. After each ascending, I can do something like yield return new, wait for seconds, and let's say something like an interval between all of them, like maybe a 0.2 or 0.1 or something. So we see how much units are actually moving over there. There might be some issues because the nodes are taking on trigger enter functions, so we may need to change all the nodes inside the prefab actually to be an on trigger collider, and same for units being an on trigger collider as well. And one or the other need to have a rigid body, I guess. So we say something like add component rigid body. Oh. We don't want to use gravity, so we deactivate that. And don't forget to save. Save the scene again and try again. And see if that works better. So they don't collide or crash into themselves. So what we could see now is multiple clones have been added. Like a total of 11, I guess. And which is good. So each of them nodes, but they're now not taking care of this one node over here. So I try again. Select this, and I want to see the numbers on top. As you can see, they do update. So if I would go and do this multiple more times, one day or the other, okay, so I don't know what is this faction now. This is now player faction, but as you can see, the material has not been changed. So the material on this is still gray, and which is actually not the correct one. So we need to take care of this one as well. But we are close. Literally, we are close to having all the mechanics done. Maybe I reduce this number here, so we can send the units a bit faster over there. Maybe I go and instead of waiting until everything is done here, we may go and per iteration we destroy one unit. Or what do we need to do? No, we don't destroy any unit. We just say per each iteration we probably go and say current amount minus minus. And we want to update the actual amount text over here in the node. So it's probably better to do it this way. So it's looking more visualized. We have now a so this node here now should be a player node. It just doesn't update the material. So that's what we need to do now, is handle incoming amount over here. It's going to change the fraction. It's producing the units or even destroying the units, which works 100% good as it should. And we just don't call the fraction handler. So in that case, we need to say fraction handler, and we need to pass in the f. So the fraction we need to change to. So, but we only do this if the current amount is smaller or equal to 0. Oh, and the actual unit hasn't changed its own material. We need to take a look into this as well, I guess. Or no, they did. They changed their color. Pretty good. So as you can tell now, we have the basics over here. We can also fill in these nodes by the other nodes over there. There's of course a problem that whenever this one is the selected node over here, we got them from this node and we didn't took the current position at this point. So, and this is actually bad. So we need to make sure that we not just use this node. So each of them nodes is literally possible to take. Or in this case, the selected node should be the one who is going to create the units from the point of the actual, from the actual node. So whenever we create that, we want to make sure that we use transform.position and quaternion.identity over here. Let's try again. Of course, NPCs and enemies should not be selectable. We didn't took care of them yet. But let me try to take this place. No node selected. Okay, so I can now, I should be able to send from here to here. Pretty good. Can also send from here. Now I have 3 nodes. Even the blue player should be able to take some. Pretty good. As you can see, works like a charm. And they all keep on creating. Oh, I didn't want to make this one an NPC node again. Actually, the selected node is okay. So something is wrong with this node handling. Oh, because we don't change the actual colors of NPC nodes. Okay, so final step should be just making sure that we are only able to select nodes of our own fraction, in this case of the player fraction. So, and this is probably done by the input manager. So if n is not equal to null and n dot fraction is equal to fraction dot player. No, not NPC, player. Then we are able to handle selected nodes. Otherwise, that should be a double N. So the AND operator contains two N's over here. So if the selected node is not equal to null and the fraction is a player fraction, then we are able to select the fraction. Otherwise, should not react. Let's try. A clear console. Press play and see if I can select this node over here. No deselected, so it tells us no, there's no way to select it. Now this node is selected. Oh, I need to hit. This is actually not as it should. Because handle selected nodes with a null is not going to be correct, so we need to put in an else if statement over here, which says if it is equal to null and also contains the player fraction, so only then we are able to handle the selected nodes. So we basically need to double check the null statement over here, I guess. We can also put a null around it and then just do the player fraction, so we don't need to check for null twice. But that's okay. So let's try. Okay, I can't select the second node over here because that doesn't make sense at the pretty moment. So where do we do this? We can only send the actual... We need to select the other ones. So we cannot do this directly in the input, it seems. We need to do that somewhere else. We are only able to send units if the selected node is the fraction we want to play. So end selected node is equal to, or a selected node dot fraction is equal to the player node, or in this case the fraction dot player. And otherwise, what do we want to do otherwise? Probably want to deselect all the nodes. I don't know, maybe. Let's try that. Yeah, bug fixing is the worst thing at the very end. So whenever you are literally done with doing things, you just need to, and for fine tuning or for the last pieces, this is going to be the one which is going to be the most things which can be troublesome. So as you can tell, pretty good, works. I can select nodes, but I can't send any units. Okay, so basically this is really bad handling, I guess. So we are literally close to where we want to be. I can select this node, but I should deselect it afterwards. So basically, if the selected node or the selected fraction is not equal to the player fraction, then probably I want to deselect all the nodes. Sounds weird, but probably that is going to fit our issue. So we cannot use the actual fraction. So we are here. Handle selected nodes gives us now the issue for the line 49, which is going to be this fraction check. So, but if we select this one, I cannot send over any other units. But if I select the red one, again, gives me issues. Maybe I should do that over here and return if the selected node is or the selected fraction. Oh, actually it's not selected node. Oh, maybe it is. Let's see, if the selected node is equal to node, we nullify all. Maybe we can do the fraction check here. Not quite sure. What is that now? Not quite sure. What did I do? I gotta put this here. Gonna copy that. So if it is not a fraction, then we deselect the node and return at this point. So we are not able to select this node at all. I hope. Let's try. Maybe this gives us another issue later. I don't know if I deleted that now. I hope. Line 20 gives me now an issue. Actually, we probably want to go with node.fraction. The downside is with node.fraction, I want to make sure that the second one we want to select is probably not reacting correctly over here. It's like if selected node is equal to null, then we nullify the null here, of course, or the node. But if the selected node is not equal to the node, we don't check the actual fraction over here. Maybe I get rid of that for the moment and see where I could go and do the fraction check. Oh, maybe I'm gonna copy that first. If selected node is equal to null and node.fraction is equal to player, then we can make this one a selected node. That looks better, maybe. Yep, let's try. Clearing console, selecting this one, node selected, selecting this. I selected the visit node. I tried to select this one, but I can't. I don't get any response if I do this. I only can select red nodes, it seems. So let me try to overtake this node. So I have two nodes now. And I should be able to select this, and I can also send back and forth these units, and I can overtake this node here as well. Pretty good. All works as expected. Final thing, basically is only just doing a win condition, something like if computer or if the enemy has no nodes left, which means we need to store the corresponding nodes totally somewhere. We should be able to do that here as well. We should be able to get the enemy at this point. So as you can see, we can populate all the nodes with our units. We can create a bunch of things, can select multiple nodes one after another, and they can give us whatever they have, and then we can populate them, and we are the winner of the game. Oh, awesome. So, pretty simple thing, I guess. Well, the fraction thing was the one which was actually, well, not cool, not the best thing in the world. And the next step would be just, you know, go and get or make the player or the AI. And, well, AI is a different story once again, which is going to take another route, literally. So currently we have only created player input, and the next thing is for AI input. I don't know if I will continue right now with the AI, because that can be rather complex, because the AI needs to know which nodes it owns, how much they have, and if they had a chance to overtake specific nodes. And you don't want to make the AI to give too much might. AI handling can be super hard in the end. So depending on how much calculation we give them, probably give the AI some cheating, like seeing how much do I have against the player. But that would be the challenging part in the end. I make a small break, and probably you have now some questions running, and if so, feel free to put them inside the chat. I make a break now, a little one. No questions so far. Okay, then we can pretty simply, as the last piece over here of this video, I guess, because now coding AI might take another 2 hours or something like that, and I'm live over 2 hours already. We can pretty quickly take a look how to design an AI. So an AI can have multiple states. It can have a collection state probably, and a text state. And it needs to know a lot of things. It needs to know how much nodes do I have, what is the amount of nodes, and what is the what is my current state, probably what is the player state. So the AI needs to know literally anything. And depending on if it is an easy one or if it is a hard AI, we want to make it more aggressive or even not. So to be super aggressive, we can say, okay, whenever your numbers are higher than the numbers of somebody else, go there, no matter what. Also, do something like fill up front spots. The AI does not know where front is, but probably making a little plan, a hidden plan, like where it says, okay, do this and do that at a specific amount of time or whatever. So there's time-based possibilities. We can make it a bit more smarter. So what does an AI actually need to know? Again, it needs to know amount of nodes and units. And based on that, it probably also needs to know the amount of the player nodes and the player units, or actually any units. Also, it needs to know all nodes and their units. Literally, it needs to have an overlook. And again, if it is super smart or whatever it is, it can be an aggressive player, and you need to define what aggressive means, or actually not a player, but enemy. Or it can be probably a smart enemy, and you can also say, okay, it's a silly enemy. Probably it doesn't do anything. Silly in this case could be something like a decision making takes this and that amount of time. I wrote an article on my website, OctoManGames.com, my latest, in which I explain a bit about enemy design. So probably you want to read out over there. Just check out OctoManGames.com. Let me type it down for you, OctoManGames.com. Just check it out. It's very much in the bottom. And in there, I write about a decision tree, or a decision making, I would say. I can explain pretty quickly what that is. An AI has a chance to perform an action, and each action, or it has a potential of, let's say, 100%. And then each action, based on the setting, is it aggressive, is it smart, or is it silly, it can do different things. It can do this one, it can do this one, it can do this one, and even more. So, and with the chance of, let's say, 35%, the enemy can do this action, whatever the action is, like take another node. So take over the closest node, for example, or take over any node which fits the numbers. Then we have another decision node which can make, okay, grow or wait. Like, don't do anything, just wait, maybe with a chance of 10% or 20, I don't know. Wait until, I don't know, or wait for half a minute, or wait for 10 seconds, or wait until specific numbers are reached, or one number is higher than a chosen node to attack. And since, again, a silly enemy probably has different numbers here. A silly enemy maybe does an attack node with a chance of 10%. It barely attacks maybe other nodes, or it just waits for nowhere. So in this case, this waiting could be somewhere around, I don't know, 50 or 80%. So something like wait. Then we have something like attack. Then we have something like aggressively attack player, and we can also say overtake as much NPC nodes as possible, and so on. So as you can tell, each of the decision ones can be higher or lower based on a setting the AI is going to be, and based on that you construct the code around it. So, and what this is all called, this decision tree, can also be used with a normal enum, with a state machine, literally. So we have a waiting state in which it just doesn't do anything, and after a couple of, I don't know, thinking time, let's put this here, thinking time. So after a couple of minutes or seconds, or maybe every 2 seconds, the NPC is doing a decision based on these percentage numbers. So, and then it rolls literally a dice and can say 1 out of 5 or 1 out of this, 1 out of that. It's going to perform this action or any of the other actions, depending on, again, this number over here. So all of them are going to fulfill later on 100%, or could even be more. You can also use some basic weighting, like a weight, how heavy this is. This action is going to be measured. So again, and once the thinking time is over, you wait until this, like every 2 seconds, we give the AI, okay, attack a node, or wait, or go and try to, with everything you have, maybe, attack the biggest node of the player, or multiple players, or go against other NPCs, and so on and so forth. So we give it, depending on these numbers, we give it the possibility to perform such actions. Same for NPC nodes, which are the gray ones, to create, or not just create more influence, but also be a bigger threat in the very end. But again, this needs to be done pretty carefully with these numbers, since AI can literally be pretty strong even in the first level. Like if you have like 3 nodes only and you have a rather high attack rate, you as a player probably are not able to beat this guy or this enemy. But the cool thing is, once these numbers are kind of set, you can reduce down these numbers until they fit, let's say, the first 10 levels to be rather silly. Then the next 10 levels, it could be more smart or more aggressive or something in between. Like each of them, like you can design multiple different enemy types, let's say, which are going to have different behaviors. Like one is more silly, one is more smart. Like if you have multiple enemies in the game, you're gonna do this, or can do this as well. I'm not quite sure how long it would take to create such an AI, but I think an hour should be in here as well. So, but I think I'm gonna stop this video right now. So I think for a rather simple prototype, that is going to be a good number over here. We did a lot of things over here by creating multiple nodes. They don't have to be connected to each other. It doesn't really matter. Later on, again, you can do some visuals, like from the selected node. You can, I don't know, enable some selection ring object or something like that, or you highlight this, or you make this one bloom or glow, or do whatever with the selected node. And then you can, when this is selected, you can draw an image from the center to the mouse, actually, or create a 3D object which always points to the mouse and rotates to the mouse from this point, and stretches or scales over size as well, so you're gonna see and like an arrow going on and so on and so forth. But yeah, this is basically everything I guess we are going today for State.io. If you want me to produce or create an AI video to this point, or a live stream for that, make sure you comment down below. Let me know. Also let me know what you're probably struggling with, and I think I will put this prototype whenever I can onto my website, so you probably can grab it for a small amount of currency. Good. Once again, if you want to learn more about game creation and content, check out the video description down below, in which you find multiple courses I have created over in Udemy. Also, check out my sketch, what is it called, Skillshare. I have some courses over there as well, which probably, or which most of the time are the same as on Udemy. So check them out, see if you can find anything what you like, and please, and keep on learning. Thanks for watching. I hope you learned something today about prototyping ideas of somebody else, and make use of it. Thanks a lot for tuning in once again, and I hope you had a great day and time with that, and yeah, enjoy the rest of the weekend or whenever you are watching this video.